Welcome to a crash course on the mechanisms and relevance of power factor. We will begin by looking at the relevant formulas that determine power factor. As shown, there are a few different methods that can be used to find power factor. Feel free to pause the video here and bookmark it for when we work through some power factor examples later. We can see that power factor can be found using apparent power, true power, and reactive power. But what are these and what do they mean? They can be described using a simple analogy. As seen on this homebrew diagram, the beer in the glass is representative of true power, which is the electrical power that does the work in a device. The head of the beer represents reactive power, which is useless when it comes to providing power but serves other functions within the circuit. The glass itself is indicative of apparent power, which is the combination of both true and reactive power. As shown in these phase diagrams, purely resistive circuits will give the ideal power factor of 1, whereas inductors will decrease the power factor and capacitors will increase the power factor. These concepts are best shown with examples. In this example, we have calculated the power factor to be 0.786. You can pause the video here to view the working. This power factor is below 0.85, which is considered to be unproductive. However, this can be remedied by introducing capacitors. Through adding a 70 microfarad capacitor to the circuit, we increase the power factor from 0.786 to 0.999. which is very nearly close to 1. Also note that by increasing the power factor, we also increase the current, a trade-off to manage poor power factors. Unlike the previous scenario, this example shows two circuits with the same true power and energy source, but different power factors. In this case, circuit 2 with the higher power factor runs more efficiently with less current required. Why is it important to understand power factor? Essentially, poor power factors mean that your everyday consumers of electrical power are drawing more electricity for the same amount of work required, which overworks devices and leads to paying more on utility bills. So, if you want to preserve your devices and bank account, power factor should be a key consideration.